So this obviously motivates the question of, is soil restoration possible? Could we actually reverse the long-term historical pattern of soil degradation? And as I was talking about yesterday in our yard, my wife, Anne, my co-author on The Hidden Half of Nature, really taught me how fast people can restore soil if we apply the things that we have at our disposal: organic matter, labor and energy, and some biological assistance through the microbial world. In other words, we can rebuild soils surprisingly fast, a lot faster than nature does. It may take her 500 years to 1,000 years to build an inch of soil, but Anne showed me that she could build a couple years of soil, of reasonably fertile soil in our yard in less than a decade. And there's some societies that I didn't talk about yet, but I write about in the book, that actually built soils over the long term. And fertile carbon-rich soils have been built by anthropogenic activity in both the Amazon and reclaimed seabeds in northern Europe. The famous plowed soils in Europe, shown there on the screen, are, you see that rich black earth overlying what used to be beach sand. When the Dutch started to get hemmed in by their neighbors and their population kept going up, they started to reclaim land from the sea. How did they do it? They walled off parts of the sea, drained it, and then they returned their urban organic waste, organic matter, back to the land very aggressively over the course of decades to build what are today still some of the most fertile soils in Europe. They built those soils essentially by hand. Native Americans in the Amazon basin built the famous terra preta soils, the black earth of the Amazon, in an environment where if you go and just dig randomly in the forest, you tend to find very poor soil. Why? Well, in that environment, the organic matter that falls to the forest floor tends to get recycled fairly fast. It doesn't build up so much in the soils. The natives of the region essentially used the ashes from their cooking fires and their waste, returned them back to their fields to build the fertility of their soils in ways that basically produced the most fertile soils in the Amazon that sadly today some of them are being dug up and exported to the urban environment and sold as potting soil. The point that I want to make though is that human activity can actually build fertile soils even as we use those soils to produce food for ourselves. It's all about how we do it, how we farm. Why would we bother trying to restore soils at a global level? Well, I'd argue that it's to address some of the major global challenges of the 21st century. Because restoring healthy, fertile soils to the world's croplands on a large-scale basis and restoring much of the cropland that has been degraded could help us feed a post-oil world. This is going to be a challenge, and we need creative solutions for it. Soil restoration could help with that. It could help us with carbon sequestration and dealing with wrestling with the issue of climate change. There's actually a lot of potential to store carbon back in soils to rebuild the soil organic carbon levels. Restoring soils could help with public health and city livability, and could help with the problem of biodiversity and environmental degradation, again, as we were talking about and mentioned last night. Now, restoring soils and the fertility of soils isn't going to solve all of those problems, but it could be a foundation for partial solutions to all of them. There's very few things, I think, that you could propose as singular actions that could contribute to the full spectrum of environmental problems that we're facing in this century. Soil restoration, I think, could be the foundation for efforts that could help with each of those. In terms of the question of feeding an agricultural world, we're really sort of at the time of peak oil. Whether it's now, a few years ago, a few years from now, is probably not the question. The question is really how are we going to maintain agricultural productivity on the far side of the peak oil production curve as we face a growing human population. It's projected to peak out at somewhere between 9 and 11 billion people by about 2100, and you can choose your own demographic projections, if you will. But the problem is we're going to have more people to feed, and if we continue degrading agricultural land at the pace we have in the past, we're going to face an even greater challenge keeping the world of the future fed than if we were to even maintain the soils that we have today. Increasing the fertility and productivity of the world's degraded soils could help us with that problem. And the problem can be captured in terms of, well, how are we going to feed a post-oil world without cheap fertilizer-intensive agriculture? If the cost of fossil fuels continues well, if it rises this century as one would project from the potential supply limitations that may be coming down the road, the question of relying on 10 calories of fossil fuels to produce 1 calorie of food starts to become sort of bad math. How will we actually try and maintain production? Well, a number of us have called for changes in agricultural practices. You could call it a brown revolution, a greener revolution, a new agricultural revolution. There's lots of labels that this could go by. But the idea of using cover crops and diverse crop rotations to boost to maintain crop yields and to minimize inputs, and the use of that with no-till farming and or organic farming, and particularly the combination, which still needs to be worked out in some ways, that can actually compete with conventional agriculture in terms of yields. There's a transition period, but it's actually it's shockingly short, in the order of 3 to 5 years from the studies that I've seen in terms of the time scale to transition from conventional practices to organic without much of a loss in yield. And those practices can also greatly exceed production using conventional techniques on degraded land. In other words, we could think differently about how we try and restore some of the land that's been degraded by agricultural practices. And if you think about the problem, rebuilding soil and soil fertility on degraded land is really going to be essential for sustaining agriculture in a post-oil and therefore post-cheap fertilizer world. When that world arrives, whether it's in 20, 30, or 200 years, is simply a question of the matter of time scale. We need to be thinking ahead of the curve so that we can proactively change practices so we don't turn what could be a problem into a crisis. If we think of soils and climate change, the thing that I mentioned, I think, last night that a few people are aware of is that by the late 20th century, fully a third of the carbon that had been added to the atmosphere since the Industrial Revolution came from degradation of soil organic matter. It came from plowing up the plains in the American Midwest, in Eastern Europe, in Western China. So a lot of carbon that has been added to the atmosphere didn't come from fossil fuels. It came from the degradation of the rich store of soil organic matter that we have in this world. There's twice as much carbon in the world's soils as there is in the atmosphere. If we can rebuild the carbon content of our agricultural soils, it will help to draw down carbon from the atmosphere. The question is how to do it and how much we can put back in. Well, that depends on how we practice agriculture. If we could practice agriculture in ways that are tailored to greatly increasing soil organic matter, there's several ways to do that. No-till agriculture, cover crops, basically stopping plowing is would be a major contribution to that. And so would the idea of biochar, the idea of taking organic matter, pyrolyzing it or burning it in a low oxygen environment to basically produce charcoal, which is highly concentrated carbon that is relatively inert, takes a fairly long time to break down, and can serve as microbial hotels that actually help spur fertility and nutrient cycling, like I was talking about yesterday. Estimates for how much how much carbon can be sequestered in soils vary quite a lot depending on who you're listening to on it. The point that I want to make today is that we have opportunities to actually rebuild the carbon store in soils that would help not just sequester carbon, but help rebuild the fertility of soils. Ron Amundsen, for example, the soil scientist at UC Berkeley, 14 years ago, noted that cultivation and deforestation releases about 4 gigatons of carbon per year into the atmosphere. That's equivalent to more than half of global fossil fuel emissions. In other words, the practices we have on the landscape are a big problem in terms of carbon emissions on a scale that starts to be comparable or a good fraction of what it is in terms of fossil fuel emissions. In other words, the carbon problem is not just about tailpipes, it's also about how we treat land. And Ratan Lal, a decade ago, the eminent soil scientist, wrote that he estimated that changes in agricultural practices could actually offset on the order of 10% plus or minus half of global fossil fuel emissions. That could be actually a good down payment in terms of reducing emissions. It's not going to solve the carbon problem, but it could help not just solve, it could be a down payment that would also help solve the soil fertility problem. In other words, what I'm basically arguing for is that it's time for a new view of the soil. We need to think about soil in a different way. We need to think about it not in the ways that we have thought about it as we've created the problem that we have with soils today. So how have we thought about soils in the past? Well, for much of our existence, we thought of soil as a mystery. Fertility was to be personified, deified, and revered. This is Ceres, the goddess of cereals, the goddess of grains. And, for a lot of our history, we viewed soils as that kind of a mystery. We also viewed soil as a means since we have been farmers for the most of our history, most of us have viewed soils as a means to a living. Land was there to be worked. That's as true for farmers today as it was in the past. The question, of course, is how we work the land. But come the Renaissance, soil started to be viewed as a decipherable mystery. It was something we could study, something we could understand. And the famous words of Leonardo Da Vinci, who wrote that we know more about the movement of celestial bodies than about the soil underfoot. His words are as true today, 500 years later, as they were when he spoke them in his day. We've learned a lot about both realms, but the things that we're discovering today about the universe of microbial activity in soils and its relationship to fertility of the soil and the health of plants is exploding in a way that shows just how far we still have to go in terms of understanding fully the processes in the soil. In the 19th century, we came to view soil as a chemical reservoir, a medium to be fertilized pretty much as needed. If you just added the right elements to the soil, it could bolster crop production. Fertilizers were very effective at boosting soil production on the already degraded lands in Europe and North America. They seemed like miracle cures for flagging soil fertility, but they came at a price, and they had a very limited perspective that didn't look at the biological basis for soil fertility in many of the world's soils. In the 20th century, we started to look at soils as an industrial commodity, something to be used and used up. What do you do with the least valuable input to any industrial process? You don't worry about conserving it. That's the part that you use up. We tended over the course of mechanization and industrialization of agriculture in the late 19th and throughout the 20th century to basically think of soils that way. We didn't think of them as the most fundamental and valuable or invaluable element of agricultural production. We thought about them as essentially the least expensive aspect of it. Today, over the past 20 years or so, we've started to actually realize how much soil really is in itself an ecosystem, and it's something that we could actually understand and work with in terms of agricultural production by trying to actually partner with our microbial allies in the soil and to be perhaps more clever in an ecological sense, in the scientific definition of ecological thinking, in terms of maintaining diverse crop rotations and not being predictable in our rotations in terms of pest management and all kinds of elements for aspects and techniques of biological pest control. There's a lot of things we can do in terms of applying soil ecology to defining the future of agriculture. And I think we need to integrate the insights of soil ecology with agricultural technologies if we are to feed the world based on ecological processes and nutrient cycling. And to me, this is really the challenge of the 21st century. How do we actually it's not a question of sort of going back to ancient farming practices. I mean, after all, those are what did in Greece and Rome. The question is, how do we actually take the kinds of scientific knowledge that we have today and the agricultural technologies that we have access to today and use them in ecologically wise and intelligent manners to foster and maintain long-term agricultural production. And I think there's some guidance that we could take from the principles of conservation agriculture. As laid out by the FAO, you can think of it in terms of three basic elements that a long-term sustainable agriculture would need to have. Minimal or no disturbance of the land surface. That could be a direct planting of seeds or no-till agriculture as an element of that. Permanent ground cover, retaining crops that including cover crops and rotations, and planting diverse crop rotations to maintain soil fertility, but also to break up pathogen carryover. Each of those things individually won't solve the problem. Doing all three together gets us a long way down the road towards solving the problem. And I'll suggest to you that that's not in that context, it's not really a question of low-tech organic versus GMO and agri-tech. I think that's far too simple a dichotomy to actually lay out. The question, I think, is really of how to apply an understanding of soil ecology and soil building to the applied problem of profitably increasing and sustaining crop yields in a post-cheap oil environment. And frankly, I think we're going to need sort of all the tools in our quiver to actually be able to pull this off over the next century. But I think we need to reframe some of the discussion and argument about how is it that we're going to intelligently apply the science that we have at our disposal, which we are not doing today in the broad sense, to the long-term problem of sustaining soil as an ecological system and promoting the life within the soil as the root and source of the life above the soil and the production of crops that we need to sustain ourselves. So healthy soil, I think it's not a silver bullet for solving the world's environmental problems. I'm by no means suggesting that. But I do think it's a secret weapon. Why is it a secret weapon? Well, because we're not actually really using it at a policy level in a way that I think that we really could. But because restoring soils could really help us address the problems of feeding the world, the problem of climate change, the problems of public health, or physical, mental, and social health, the health of the food that we eat. All those problems, I think, solutions to all those problems could be founded, need to be founded, in a long-term respect for healthy, fertile soil and efforts to actually rebuild for healthy, fertile soils. Because healthy soil is the foundation for human health and the foundation on which environmental health are to be built. It really does all start with the ground beneath our feet. And finally, I think that the first and foremost argument for soil restoration, it means, quite frankly, we have to stop treating soil like dirt. Thank you.